In this task, we will delve deeper into transformer-based models. As we previously mentioned, transformer-based models are primarily used for natural language processing tasks. The transformer model uses a self-attention mechanism to attend to all words in the input sequence simultaneously, thereby capturing long-range dependencies and context more effectively than traditional natural language processing models. Now, we will attempt to briefly explain the architecture of a transformer in simple terms, keeping in mind that it is a rather complex structure. In the architecture of a transformer model, we have two main components: attention blocks and encoding layers. The attention blocks represent the model's capacity to focus on different parts of the text. If we examine a sentence, some words may have more influence on the meaning than others. The attention blocks aid the model in identifying these keywords and understanding their interrelations. On the other hand, the encoding layers serve as layers of knowledge. Each layer in the transformer model learns something new about the text. For instance, in the first layer, the model might learn about the basic sentence structure, while subsequent layers might learn about word meanings and more complex relationships. The transformer model processes and comprehends the text by moving through several encoding layers and utilizing attention blocks in each one. As the model advances through the layers, it captures increasingly complex and deeper information about the text. Once the model has processed all the layers, it can use this accumulated knowledge to perform specific tasks, such as text translation. We can illustrate this with an example of transformer architecture. We can observe two distinct blocks, the encoders and the decoders. The encoder processes and comprehends the source text, capturing its meaning and structure. It then relays this information to the decoder. The decoder uses this information to generate the desired output, translating the input text in the case of translation. Both components work together to transform the input text into a meaningful outcome. It's also worth mentioning that the encoder and decoder share similar structures in terms of attention blocks and encoding layers. However, as we previously mentioned, their roles differ. The encoder's aim is to understand and process the source text, whereas the decoder uses the provided information to generate the output. So, what do these components comprise? We have a simplified schema of the encoder and decoder structures here. It includes the previously mentioned attention layer, along with the encoding block. As we noted earlier, both the encoder and the decoder share similar components, namely the attention layer and the encoding layer. As we previously stated, one of the most common uses of the transformer model for generative AI is language translation. Thanks to its ability to discern patterns and complex linguistic nuances, the transformer model serves as a powerful tool for generating high-quality text in various contexts. Therefore, transformer models are employed for tasks related to natural language processing, such as language translation, text generation, and summary generation. As we can intuit, the capabilities of working with text in ChatGPT are primarily based on these transformer models.